Oh, hey guys. Well, I pulled up the ISWA run on the magnetosphere and went to the CCAT, which displays the solar wind. There's the magnetopause, and there's the Y-cut with the closed field lines, the polar cap lines that normally just stream out from the Earth, and there's the blue IMF field lines, interplanetary magnetic field lines. We had some serious space weather going on yesterday behind the planet. Here you can see a huge amount of pressure building. I got these radiation belts pulled down here because they're not showing a whole lot of deviation. So that the Earth's magnetosphere, I think it's marshaling its forces and it's concentrating on all this backside pressure. But here we got it at 2025. This is at 2009 yesterday, UTC. So that's what, about 3 o'clock or something Eastern Daylight Time. Anyway, watch the solar wind numbers. 1196, 1328, and then expels all that energy that's building up back here. It goes, then it comes back again for a second run, a second expulsion, 1099. Then it quiets down for a little bit, continues streaming out the plasma energy that's coming from behind the Earth. And then it happens again up here. Well, it does happen again. Well, I showed you twice it happened. Maybe that's what I was thinking of. This isn't scripted. I'm just free flowing here. After looking at all this stuff, I'm trying to give you a recap of what I saw. You see here, everything's going along at 405, 409, 417, then it goes to 828. So we got 4 hours and 11 minutes of missing time there. So no telling what happened. And then always when you got a big time gap, when it comes back online, you see some more huge plasma energy being discharged. So I would just have to surmise that there must have been an event even worse than what happened back here at 2033 when we had 1328 on the solar wind speed. Now these are the geosynchronous satellites that are recording all this data and generating these computer simulations. They're going around the Earth at 22,236 mile altitude. Goes 13 and goes 14. Those are the ones that are collecting this data and solar wind speed and everything else. Because if you look over here, this is from the Discover space weather satellites, the newest one they put up. NOAA Discover. It's meant to replace the ACE one. It's orbiting at the L1 Lagrange point. That's out here, 930,000 miles in front of the planet. So it's recording all the solar wind data from the sun. And as you can see here, the solar wind is quite normal, even below normal. Normal's 400 to 700 roughly. You can see these solar wind numbers as you move the cursor along, and it gives you the time up there. So at 2033, 33, 34, whatever, 32. we only have a solar wind speed of like 423 miles per hour, and you can see through the whole run, never really got much above 425. So still got some crazy stuff going on here. Now here it is on the Y cut. Start it from the beginning. 1621. So you can see these field lines. These are streamers. They're extreme solar wind from the sun away from the earth, the black ones. So you can see they're getting jumbled up, and then here comes the pressure. So Earth's trying to close it off, and it's closing. Some of these streamers are closing up. The black ones, they're turning into closed field lines. Normally they're all tight to the planet, but as you can see, they're way out there, the red. And then we had a little bit of an expulsion there, and they're balling back up. And here's where you have the huge expulsion at 2033, where we had the 1328, 1227, 1328, 11. So it's right all in there. Kilometers per second, which is over 3 million miles an hour. By the way, so you see the red lines, they balled up, and somehow Earth was able to expel all that energy that was building up behind the planet. And there they go. The red field lines are all closed, trying to ward off this energy and just push it away from the planet. And then it comes back a little bit to normal, but then I think we had a secondary one there at 2218. Watch the solar wind speed numbers, and watch the arrows too. So there's another one, see, building 9. Then it expels it at 1178 kilometers per second. You can see the arrows all pointing away from the Earth, trying to get rid of this. You can see it on the bow shock. I was looking at this, and normally this thing sits about 10 Earth radii in front of the planet, and then handles all the solar wind pressure coming from the sun. This is the Earth, this little circle here. I don't know why they have that black occlusion disk on there, but just for visual purposes, I guess, as far as I can tell. I haven't figured any other reason for it. But anyway, there's the sun side of the Earth. So normally this bow shock, the magnetopause, it's called, sits about 10 Earth radii. And the Earth is like 3,959 miles radius, so somewhere around there. So here you watch, I mean, it's being pushed out from all the pressure. See how it's still staying above 10? And then there's 2013. That's when the Earth's starting to try to falling up these field lines. They're getting closed, and you can see it's marshaling its forces. So the bow shock came back down almost to the 10, and then that's when it expelled the energy. You can see the energy's leaving there, and of course, equal and opposite reactions. There's like a big explosion behind the Earth, so then that's bowing the bow shock out pretty far in front, almost to 12 Earth radii. Then it quieted down for a second, and it's balling up again, and that's where we had the second discharge. But as you can see, I mean, this pretty much relentless pressure behind the planet. And that's 417. That's when it jumped to 828. And you can see still a lot of pressure coming from backside. You can see a little bit of energy bleeding in on these things, but nothing like too crazy. So you can watch these here. There's the timestamps. So that's right around the 20 when that big thing happened. And well, I mean, we got a ton of energy bleeding in around the planet 24/7 now, pretty much. This is a low energy electron count at the lowest 10 keV count. That means these electrons aren't traveling quite as fast as these high energy electrons. They're traveling the fastest of all the simulations they make available. And it's at 4,000 keV or 4 MeV. So we got the blacks and the purples, so that indicates a high electron count to me. And you can watch these too as we look at this stuff. So let's start this at the beginning. This is 1617 UTC yesterday. Watch the arrows. See how we got the arrows pressing toward the earth? Like I was showing you on the bow shock. And there's something happened there at the 18. There's 792. So in the 700s down to 6 again. That's the big event. So anyway, that's about it for today, I guess. I looked at the geospace. That wasn't showing anything that was relevant for me to describe as far as making a video of what we got going on here. So I mean, we got the missing time. Oh, we could show you that on here, I guess. So it went from, here's the missing time, right around 4:17. That's when this thing quit and went to 8:36. So something clearly happened there. No telling what. I would imagine something similar to what we've seen back there at 2033. But maybe it was worse, or maybe we had a complete magnetopause reversal, because I mean, get some serious backside pressure. And the geospace ones, they don't go back as far. They only started around just today, so they only have about a 4 or 5 hour run, 6 hour run, and they weren't relevant to any of this stuff, so that's why it wasn't worth putting on. Anyway, I'll leave the links below. I don't know. I'm getting a depressed sense of what's going on here. I don't think I've never felt quite like this. Put it that way. Things are getting worse. And I'll keep checking them, and as things warrant, I'll post another video. Thanks for listening, guys. God bless. Peace, and I'm out.